Hey everybody, welcome to Bill Sky the C Guy, and this is my third video in learning the C programming language. And if you didn't watch the string video before this, I really recommend that you do because we're going to be messing with that. And what we're going to do today is we're going to talk about how to print things nicely formatted on your screen using Printf. Also how to do it both on stdout, standard out, as well as stderr, standard error. And before we actually go into the coding, what are those things? Well, when you normally do a printf or a cout or a print or a putS, that goes to what we call the standard output, which is pretty much just the screen, the terminal that you're working in. Now, if you're working in graphical user interface, that's a completely different situation. You're not even going to use those necessarily. So that's what stdout is, standard output. stderr is standard error. Where do you want error messages to go? And the really cool thing about that is that you can have error messages go to like a log file or an error file. Depending upon your IDE, integrated development environment, it might even do things in a different color. I believe that's what it does on Eclipse, which is what we're going to be messing around with here. So let's just get right to coding using Printf. Okay, I have my Eclipse up here and running on Linux. Now you can do this on Windows, you can do this on Mac, it doesn't matter. It doesn't matter the IDE. And I'm going to create a new C project. And I'm just going to call this Printf. I don't think we're going to get to any debugging using Eclipse. If you want to mess around with debugging, go ahead and take a look at the previous video on C strings, because we've got a lot of stuff going on there with debugging. That was actually a pretty good video, I think. Okay, so let's take a look at what we've got. So what we've got in this initial program is that we've got this thing called putS. And now what putS does is putS just puts a string out on the screen. Let's go ahead and let's create an integer, and int equals 999, and let's try to do a putS using an int, and let's see if it'll even compile. And it gives you an error, but what it's going to do is it says here it's going to make the pointer from an integer without a cast, so it's going to print the pointer to the integer. Let's see what happens when we run that. Well, it didn't print 999. It really didn't print anything. And the reason that I showed you that is that putS is extremely limited. PutS is really just there to print out like informational strings. So I'm going to say putS program ending. So putS is really limited. The other thing that putS does, whether you want it to or not, it always puts a new line at the end of the print. So if you want to print multiple things on the same line, or you're going to be doing some creative things with output, you don't want to use putS because it will always put a new line on there. So let's get started with this thing called Printf. And what Printf is that it is the standard way of printing things to the screen. And because we're going to be messing around with strings, let's go ahead and do a couple of includes here. I'm going to say include string.h, and I'm also going to say include time.h, and you're going to see why we're doing that. So we have an integer here. Let's go ahead and before we actually do the integer, let's go ahead and print a string. So I'm going to create a C string called my name. And I'm going to make it equal to Bill Sky, the computer guy. And then down here, I'm going to go ahead and print my name using Printf. Now I'm going to do it the longhand way because it's very instructional to do it this way. And we're going to talk about the format of the Printf just by this example. So if I want to print my name, I could say Printf my name. And let's go ahead and save and build that. And let's run it. And it prints Bill Sky, the computer guy. Notice it did not print a new line. If I want to print a new line, I have to somehow put a \n there. I could put a \n right here, but I don't want my name to always print a new line. I don't want that \n to be stored. So how can I actually put a \n in there? Well, what I'm going to do is I'm going to create a formatting string right before the variable that I'm going to print. So I'm going to say double quote, and I'm going to say \n, double quote, comma, and then the variable I want to print. And let's see what we get. Okay, I'm going to run it. And we got the new line. You can see the blank line between the hello world and the program ending. But where's my name? That didn't print anywhere. Well, that's because Printf needs to know what is the data that you're going to be printing. And it does that with formatting keywords or characters or syntax. So what I'm going to do is I'm going to say %s, and that means a string is going to be following. So I want to put the value of this string where the %s is, and then follow that with a \n. So let's go ahead and save and build that and run it. And you can see Bill Sky the computer guy, and it went to the next line of code or the next line of output, which is program ending, because we have that \n there. And again, if I take that away, just as a reminder, if I take away that \n and build this, you can see the \n is gone. So again, it gives you much more control over the formatting of your output using Printf. And I think strings are probably the easiest. What if I want my string, and let's build and run this again just so I know where we are. Okay, there we go. So let's say we want the string though to be in a much larger column. Let's say we're creating a report, and we want that name to be in a much larger column. Right now, it looks like it's left justified, and it's just the width of the column of the data is just the width of that C string. Well, I can go ahead and put a number. Let's say we want that thing to be in an 80 character column. So we can say % and the width of the column, and then the fact that we're going to be doing a string, which is that S right there. So what we're doing here is we're doing some IO manip stuff. If you look at IO manip on C++, there's a width syntax that you can send to the cout. And let's go ahead and run this. And if you notice, it's right justified. So Bill Sky the computer guy is a string that's within an 80 character column, and it's always right justified by default. Now if we want it to be left justified, we're going to put a minus in front of the 80. So again, this is a way to format your data the way that you want it to be formatted. And we're actually going to do a kind of a cool report in a little while. And there we go, it's left justified again. So again, you don't really need this if you're just going to be printing a string and then going to the next line. But it is a way for you to specify the exact width of each piece of data you're going to be using. So we're going to get back to that later on. Okay, so that is a string. Next is, what about integers? How do you actually print an integer using Printf? Well, let's go. We have an integer right here, an int, and let's go ahead and just say Printf and int. Again, this is going to be the same thing as we had when we first tried to do the string by not specifying a formatting character. We're going to get unknown. Yeah, see, in fact, the program even died. We didn't get to the program ending "Have a nice day" output to the screen, so it died with a -1. So even though it compiled, the Printf was expecting something. So we're going to have to put in a formatting character or string, and in this case, we're going to put in what are we going to put in? We're going to put in a %u, and then a \n, and then an int. And %u basically means an unsigned integer. We want to print an unsigned integer. Now this is a signed integer, so let's see what happens. And we're going to run it, and you can see our 999. That's great, okay? But let's make our 999 a -999 and see what we get with that unsigned integer, that u. We get something completely ridiculous, okay? So so you have to keep track of this, right? An int is an unsigned int, is a signed int, but if you said unsigned int, the %u would be what you want. We want it to be an unsigned int. So you need to keep that signage correct. Now, what if you are doing a signed int? Well, you just say %i. So I'm going to change this from %u to %i. And it's still negative 999. Let's see what we get. Remember, we got this really ugly number. And now it's really negative 999. So printf knew it was a negative number. It formatted it as such. Now, if you're wondering about why does it do it that way, why was that really strange, you can take a look at Bill Sky, the Assembly Guy playlist, and see how signed integers are stored in memory. And you can see some real good information about how the computer actually does this in memory. It's called 2's complement. It's completely alien to most programmers until you get down to the really low level assembly language. Okay, so that now what if we want to mix things, right? All you see is this negative 999 here. What if we want to mix things? Well, I'm going to put in here the value of an int is, so I can mix text in with my formatting characters or my formatting symbols to make, and it'll print them. It'll print that text. So let's go ahead and run this. And you can see the value of an int is negative 999. Pretty neat, right? I can even put stuff after it. Save it and build it. So what printf is doing is it's looking for this % sign. It's looking for that % sign to say, hey, they're going to be formatting some data, and then I'm going to take the data that's in that variable and put it in there. What if we've got two integers, though? I'm going to create an unsigned int, and I'm going to make this equal to, I don't know, 987. Doesn't matter what the value is. What if I want to have another variable? Well, I'm going to say here, %u. And then down here, over here on the far right, I'm going to say comma and uint. So I now have two variables. I have two replaceable symbols here. So it's going to take an int, it's going to place it where the %i is, it's going to take an uint and place it where the %u is. And you have to make sure that you specify the correct data type as a % sign in the formatting string that corresponds with the value later on in the statement. So let's go ahead and build that and run it. And there's the negative 999. There's the 987. Pretty neat. Something else you can do on this formatting, you can specify the width of the column. So I want the width in this case to be 10. I want the width of the unside to be 8. And remember, there's just spaces here because we've got spaces right there. We've got spaces before the percentage. But this way you can specify the exact width of the data that you want to print. And you notice now we have extra spaces because we were just saying we want that to be in a columnar type of a format. Now it doesn't make a lot of sense to do it in this, in this particular example, but it will in a little while. So that's unsigned and signed integers. Okay, so what about floating point numbers? Well, let's create a couple of floating point numbers. I'm going to create a float. I don't know. Let's call this, I don't know, my float. I'm going to make that equal to 123.45. Let's create a double. I'm going to create a double. My double equals 567.89921. I don't know, some strange number. So how can we print floating points? Well, I could use the integer, and let's try it. Oh, printf. The value of my float is %i \n. And let's see if the compiler lets us get by with that. Well, it gave me some warnings. It says %I is expecting, but let's, oh, we didn't actually put in the variable at the end. Yeah, it's interesting it gave me the warning, but it didn't actually not compile it. Okay, it's looking for a type int, but it got a type double, and actually it's a type float. Okay, let's see what happens when I run it. Well, we got something completely wrong. We got garbage. Because the floating point number is stored in memory as an IEEE format. And if you don't know what that is, take a look at my assembly language floating point video. And it's trying to convert that to an integer, and it just can't do it. So how do you do a floating point? Well, with a floating point, you might be aware, you'd say %f. That is a floating point. Now, you'll use that for doubles or floats. So I'm going to say my double and let's see what we get when we run this. Much better. Much better. However, I want you to notice something here. The floating point number is not actually stored 100% accurately in memory. That floating point number, as you can see up here, is 123.45, but actually stored in memory as 123.449997. Why? Because floating point numbers, not all floating point numbers can be stored 100% accurately in memory, and that's because it's dealing with the binary number system. So again, take a look at the floating point videos I have in my assembly language playlist, and I'll try to put a link to those in the description of the video, this video, and then you can see why, because I explain why. It looks like we're okay here on the 8999210. So that pretty much means that 567.89920 either stores very accurately in memory, or because it's a double, we've got more bits to store that number. So that's floating point. What if we just want to print 2 decimal digits? Well, what I'm going to do is over here in the F, I'm going to put that I want to store it as a 0.2. In this one, I'm going to say 0.3. So you put the number of decimal digits, 0.2 or 0.3, in front of the F. And you can see that it has printed only those 2 decimal points. 89921. Let's make this one 899921 to see if it rounds up. And it did. So not only will, if you specify the number of decimal digits or fractional digits, not only will it only display those, it'll also round it up. So it gave me 567.900. You can see that's a roundup from 89991. You can also put in the total number of characters. I want each one of those to be 12 in width with 3 decimal points or 3 fractional digits. And you can see the output has been formatted within a 12-character column. What if I want to print a %sign? So if I wanted to print, for some reason, if I wanted to print a %sign right there, well, if you do this, what's going to happen is Printf is going to think that this is the formatting string, or that is the formatting characters for that. So if you want to print a %sign, just put 2 percentage signs there right after each other, and then it'll actually print the % sign. All right, great. So that's strings. We formatted some strings. You can see that here. We also formatted the width. Let's create something kind of neat. I want to create a report. I would just like to go ahead and create a report. So I'm going to create a little for loop, and I'm going to do this live with you. So I'm going to create a for loop, say int I equals 0, I less than 10, I plus plus, and I'm just going to print some data. So I don't know, let's do a thing called interest rate. So let's do a little interest rate report. So I'm going to create a variable called interest year. I'm going to create another variable called interest. Oh, I don't want to create a integer. I'm going to create a double called interest rate. I'm going to create another variable, I don't know, double Interest earned. I'm creating a little business report to show you how much interest you've made over the year. And I'm going to create another double called interest. What do I want to call this one? Let's call it total deposit. And let's give all these values. Okay. Let's save and build this. Just make sure I don't have any syntax errors. Okay, looks good. It gives me some warnings that I haven't used those yet. And I've got my little for loop here. So what I'm going to do is I'm going to just generate some data. I'm just going to generate some random numbers. So I'm going to say, I don't know, interest rate or interest year is equal to the year 2000 plus 1. Now what am I doing? I'm just generating some test data so I can print a nice display. Okay, I'm going to say interest rate equals, I'm going to use the rand function, so I'm going to say random. I want the interest rate to be between 0 and 8%. So I'm going to do a random modulus, and then I'm going to divide that by 100. Now why am I dividing it by 100? Because I want to take the number that it creates, which is, let's say, a 7 or a 6 or a 5. I want to divide it by 100 because that's really the interest rate. That's the percentage, that's the decimal value that you use to multiply for interest calculations. So I'm just going to divide it by 100. The other thing I did was I put 0.00 there. And the reason I put 0.00 there is because if I just said divided by 100, the result of a modulus calculation results in an integer. If I just say divided by 100, it'll come up with 0. It'll always divide it and chop off the fraction. So I'm going to put .00 there to make sure that I am calculating a double value. Okay, so I have the interest year, I have the interest rate. Let's just create a deposit. So I'm going to say total deposit. And again, this is kind of like a bank, right? Total deposit, I'm going to generate a random deposit amount. So I'm going to say random, and I don't know, let's do a random of 15,000. Maybe you're rich. And I want to add the calculation. Actually, no. What I want to do is I want to create a floating point value here. Total deposit is floating point. I don't want it to always be an integer. So I'm generating the whole part right here. This part right here is the integer portion of my floating point. I'm now going to generate the fractional portion, the decimal portion, and I want it to be between 0 and 99, 0 and 100 I should say, divided by 100 so we get a fraction. So the left part right here is going to give us our integer portion of our floating point, or of our double, and this will give us our fractional point at the end. Okay, now let's go ahead and calculate the interest earned. So we have our total deposit. Let's calculate interest earned is equal to total deposit times the interest rate that we calculated. Now you can make the interest rate a constant, but I kind of like having a different interest rate, you know, because interest rates change every year, so I kind of like to do that. And it's just, all we're doing is just creating a bunch of random data here. And then I'm going to say, actually, I would like to keep track of the total interest that I've earned over that 10 years. So I'm going to create another double. I'm going to say total interest earned equals 0.00. And then I'm going to go ahead and add the interest earned for that one, or total interest earned from each year. So I'm just doing a running total. Okay. Now, it's not printing anything, but let's go ahead and build it to make sure I don't have any syntax errors. Yep, it looks like I do. What did I do wrong? 1, 2, 3. Let's see what it said. Invalid operands. Oh, I forgot to put parentheses right here. There we go. See, now it was just this little bit of code that I was working on, so I know where my error was. I just have to kind of find it. It's a lot easier than creating tons of code and then trying to hunt down all of the errors at the same time. All right, so now let's go ahead and print this. So what I want to do is I want to print the year. Now, it's always a good idea to kind of come up with a report format. So I'm going to have the year. What else do I want to print? I want to print the year. I'm going to print the interest rate. I want to print the total deposit. I want to print the interest earned. And again, I'm doing this on comments so I can kind of show what my report's going to look like. And some data might be, I don't know, 2010, I made 12%. Let's say 0.12%. Actually, my numbers aren't that big. So let's say I made 0.08%. My total deposit was $15,000. Oh, let's say $10,000. And my interest earned in this case would be $800, I think. So I would like my numbers to kind of look like, my report to kind of look like this. And I could make a copy of this. I could do the same thing for, let's say, 2011. This one would be 7%. Let's just keep the numbers easy to do there. So my report kind of looks like this. And then I would like to print a total. And I'd kind of like it to be, you know, right underneath that. So that'd be $1,500. So I kind of like my report to look like this. And maybe down here, we'll put something like this. Kind of a nice little report. I'm designing it. So let's keep that there as I put in my printf. So the first thing I want to do is let's just print the data. So I'm going to say printf. And we've got an integer. So I'm going to say percent. It's going to be an unsigned. So let's say %u. We've got an interest rate, so that's going to be a %f. We've got a total deposit, that's going to be %f. And the interest earned is going to be a %f. And then from there, I'm going to print the interest year. I'm going to print the interest rate. I'm going to print the total deposit. And I'm going to print the interest earned. Now, where did we get those data? We calculated that up here. It's just some general data that we just calculated. Okay, let's go ahead and build it. Let's run it. Okay, well, it's not... Okay, this is our first try. So first thing I noticed, we forgot the \n. Let's put a \n there. Isn't quite what we designed. All right, good. So we're getting there. So again, it's not quite what we designed. We need to have some spaces in between this data because this is basically an unreadable report. You can't turn this into your boss. So we have to kind of make things formatted correctly. It looks like the year and the interest rate is pretty good, but I don't think you need 8 decimal points or 8 fractional points for the decimal. So what I'm going to do is for the interest rate, I'm going to put a 0.2, save and build it, and run it. Okay, well that's looking better. This one here looks awful. So let's make that, because what is that? That is in a total deposit. Let's make that a 0.2 as well. All right, looking better, but it's not justified. The decimal points are at different positions. So what I'm going to do is I'm going to make this a certain width. So I'm going to say that I want this to be 8 columns wide. So 8.2. Let's see how that looks. Okay, good. So now all of my decimal points are aligned. However, we've got the same problem here. So I'm going to do the same thing here. I'm going to say 8.2. All right, very good. It's looking a lot better, isn't it? Looking a lot better. I would like some extra space between the year and the interest rate. So what I'm going to do is on the unsigned here, I'm going to say, let's make that 6 characters wide. All right, well, but notice that it right justified it, or yeah, right justified 2001, and it put some spaces in front, so maybe that wasn't the right thing. Let's leave it that way for now, and let's go ahead and make the interest rate column wider, because it's always going to right justify numeric values. So let's make that a 6. I think we're getting there. All right, this is looking a lot better. I think the interest rate and the total deposit they're too close together. So instead of 8, let's make this 12. And let's make this, let's make this 10. So all we're doing is we're playing with the widths to get a nice report. All right, this is looking a lot better. Okay, now one thing we don't have is we don't have the year. We don't have those table headers. So we're going to have to do that up here. So what I'm going to do is I'm going to copy this printf because I've got all of my widths there. Okay, and instead of U and F, I'm going to say S, 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 and S. So each one has the same column width, but they're all going to be strings. So I'm going to say, what was my design? Oh, my design was year. So I'm going to create year. That's the first string. I'm going to say, what was the next one? It was interest rate. The next one was total deposit, and then interest earned, and then \n. All right, let's go ahead. Oh, nope, we don't put that there. We already have it here, so we don't need it there. All right, let's build this. And now I know this is going to look horrible, but we're getting there. The problem now is that the headers are not really formatted or aligned with the actual data underneath it. So what do we have to do with this? Well, let's see. So we've got 6, 6, we've got 12. Yeah, the reason why it's not aligned is because the column headers are wider than 12. So like year and 6x is correct. However, 6s and interest rate is not correct. So how many characters is that? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this 6 must be at least 13. Let's make it 15. Now if we change it there, we have to change it down here with the data as well. The columns have to be the same width. So let's go ahead and run it. Okay, this is looking a lot better. We've got the same problem with total deposit. So how many characters is total deposit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 again, so let's make this 5 width, 15 width. Let's make the data 15 width. Save and build it. Run it. All right, looking a lot better. We've got the same problem with interest earned. So how many characters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. So let's make this 17. And we have to change it down here as well with the data. So we're formatting our report very nicely. All right, this looks great. This is looking really, really good. But we want that underline as well. We don't have that underline. So that one's actually pretty easy. What I'm going to do is I'm just going to copy the header. I'm going to leave all these formattings the same. And just make each one underline. And I can put spaces here if I want to make it easier to underline them. You could write a little function that prints these underlines or these dashes, but I don't want to spend another hour on this video. Okay, so let's go ahead and save and build this. All right, this is looking really good. Now, the only thing we don't have is that we don't have this total interest earned. We haven't actually printed that out. So to do that, before we do that, we want to print, or we want to figure out how long is this actual row? I mean, how long is it? Well, you can do that by totaling up these numbers. So we've got 6, we've got 15, 15, 17. So that's 30 plus 17 is 47 plus 6 is 53. So you can see what I'm going to do here. I'm going to say printf %53s, and then I'm going to put that in there. 53s, and I'm going to, I'm going to leave that there. And then I want to print a double. So I'm going to say %f, and I want that to be, I don't know, let's make it the same as the interest earned. So the interest earned is 17f, right? 17.2f, so 17.2f, there we go. And then I'm going to say total interest earned, and then total interest earned. All right. Now, is that correct? Is that correct? I believe it is. All right, let's save and build it. It looks like we've got a problem. So printf %53s. Oh, yep, %72f. Total interest earned. It doesn't look like it's going to let me do that. Let's see. First use of, did you mean total? Oh, I've got an invalid variable name. So let's go ahead and use our trusty copy and paste. Because I typed it wrong. Let's run it. Well, we forgot the \n. I do that quite often. So let's put the \n in there. Run it. Okay, looking better, but it's over too far. Did we total these up correctly? Well, I don't want to total up this one because I want this number to actually print under there. So I added too much. So I don't want to do the 17. So I want to do the 15 plus 15 is 30 plus 6 is 36. So instead of 53, I'm going to say 36. What I'm doing is I'm just jumping across to the next field. Okay, that's looking better, but I'm off by 2 spaces. Why am I off by 2 spaces? Well, I did that on purpose. The formatting string also contains spaces where it prints spaces. So you've got to take those into account when you're counting up all of these spaces. So I'm going to change this to 38 because we've got 2 spaces here that we didn't take into account with our calculations. And there we go, total interest earned. Pretty neat. Now, one thing we haven't done is we haven't done this like summation underline. So let's get that done. And now that we've got our total interest earned there, I'm going to go ahead and copy that. And this time I'm just going to leave it that way. And instead of 17F, I'm going to say 17.2, and then just put some dashes there. Actually, no, we need to space over, right? So we can either just do something like this, just put a space here. Then I want to put spaces in that 32S, and then I want to put some dashes. Let's save and build that. All right, that's looking really good. What a nice little report using printf. We've got some data in there now. All the years are the same, and that's because I added by 1. I should have added by I. Looks a lot better. Now, one thing we don't have is that we don't have a report header. So I'm going to create a report header. I'm just going to say printf %s interest income report, and put that \n there. And we want to have I'm going to put an underline underneath that just so I can show it as if it's a title. And just make this all dashes. And it might be a good idea to put a \n before the report so it doesn't collide with what I did previously in the program. Now there's a report I could be proud of. I've got a nice little header. I've got my years, my interest rate. I've got some test data. This is something I would be very happy to take to my boss and say, hey, what do you think of this? I might also want to include another. You can see that this is kind of merging with the program ending. So what I might want to do is, after the total interest earned, I could do something like this. I could say \n. Let's see what that looks like. All right, that looks really good. Yep. And I'll tell you, there's been so many times where I've had to do this, and just incrementally doing small little changes to it really can help out at writing your code. You might also want to do something like, instead, let's say if it's not interest, let's say if it's something else where you need more decimal points, no problem. You just change your decimal points. Something like this. Let's save and build it. And look at how nice that is. So now your decimal points, you've got 4 fractional decimal values instead of just the 2. You might want to change this interest earned to also have 4, which we can very easily do. And there you go. Nice report. So let me tell you, using printf is not that big of a deal. It takes some practice. It takes some. It takes practice, right? It takes you have to define the report. You have to design it before you do anything, before you actually do it. But I'll tell you, I cannot tell you the number of times as a new employee someplace, even as an old employee someplace, I had to go in and write reports based on data in a database. And the way I would do that is I would do something like this. I'd take it to the boss and say, is this the kind of report you want? Oh, this is great. No, I want this moved over here. I want this kind of a report header. You get that information from them, and then you go ahead and change it. And then you show them the next version. Next, let's take a look at standard out and standard ERR using fprintf. So I'm back here to my program, and I want to use another function called fprintf. And the way that I'm going to do that is I'm just going to say fprintf. I want to send that to stderr. And what stderr is, it's the error pipe. Where should I send error messages? And I'm going to just say this is an error, %s, just like you would do printf. And I would say test error. And I want to put a \n here. So let's see what happens on Eclipse when I do this. I mentioned at the beginning of this video that it might save it as red, or it might print it as red text, which it did. So notice what happened is that by specifying a destination using fprintf, I can send the data to stderr, and that is displayed on Eclipse in red. Now if I go into my Eclipse and if I look for my executable and I run this, it doesn't show it in red, and it also intermingles it with my normal stdout. And that's because I haven't ported stdout to a different location. I could send it to a file if I wanted to. And actually, that'd be kind of neat to try that out. Let's do that right now. So to do this on Linux is actually pretty simple. Windows, it's a little bit more involved, but I'm just showing it to you as a demonstration. On Linux, if I want to send all of the error data to a file, let's say I don't want to see this is very obnoxious, right? Now, those aren't really errors, but let's say there were. Let's say that we were having login errors during the report generation to another database or something. We don't want to display it on the report. I mean, I wouldn't want to show this to my boss. This is just a horrible report. There is valid data in there, but what if something in the background was happening that wasn't crucial to the report generation, but it's something I want to let people know? Well, on Linux, and Windows is something like this, but not quite. On Linux, I would specify the program name, and then I would put 2 greater than error.txt. And what this is going to do is this is going to port this, or this is going to pipe the standard error messages out to a file called error.txt. And I'm going to press enter. And notice how the report is very nice now. If I go ahead and ls, you can see error.txt. I'm going to cat error.txt, and you can see the error messages. So those are the error messages that were generated. You can make this more interesting so you can see that each one of those is a different error message and not the same one repeated. I could say this is an error %u, and then I could specify the value I or the counter I. Let's go back to the terminal. And because we said the 2 greater than, it didn't display anything, but if I go ahead and display it, you can see our loop counter along with the test error notification. Now, how would we do something like this on Windows? Okay, so we're on Windows 11 here, and I've got Eclipse up and running, and I went ahead and just copy and pasted that code into another Eclipse project. And this is why, this time on Windows, and this is why Eclipse is so great, is that it took me seconds to do this. And when I run this program, it gives me the same thing, where on Eclipse it shows all the errors, all the std error at the bottom, but all the std out on top. Now if I open debug and then I right click on the executable, I say show in local terminal, I have the same problem as I had on Linux. If I type printf, it kind of interspaces the errors with the output. So I can do the exact same thing on Windows as I can do on Linux. I can just say the name of the command. Let's make sure we've got that. So printf, and I can say that I want the 2, which is the standard out, to go to a file called error.txt. And so the output prints very, very nicely on the screen for my report, and then all the errors show up in error.txt. Instead of cat, I type, and we can see our error messages. Now, one other thing that you can do on Windows, you can do this on Linux as well, the syntax might be a little bit different, is I'm going to say 1 greater than, and I want it to go to report.txt. And so what that'll do is it'll send the standard out to report.txt. It'll send the errors to error.txt. So if I then say type report.txt, there's my report. So what I've done is I have separated out the output of the report to my report.txt file, and then I have output the error messages to the error.txt file. And we've got some other little things here, but you can kind of see what this is doing for us, that it's allowing us to go back and forth between errors and standard out. So that's it. So that's an introduction using printf. Takes practice, try it out. Very, very important for you to learn this skill, because there's a lot of C code out there. You're going to be asked, if you've never worked in the industry before and you get a job as a programmer, at some point in your career you're going to be asked to do something with data in a C program, C++ program. So you need to know both of those skills, C and C++, as well as, Python and Java. Reports are very important. People are always getting reports, whether they're getting it electronically or on paper. You need to know how to create a report that your boss is going to like, that you're going to be proud of, and that especially is going to be very easy for the users of that report to use. You just don't want to generate just data and then people try to figure out what's what. You need to help them get their job done. So, hope to see you at the next video.